Welcome back to the Deep Dive. We are doing something a little different today.
A little bit.
Usually we're looking back, analyzing history, or, maybe trying to make sense of the news cycle from last week. But today
We're looking forward.
today we are stepping into a time machine. Well, a very short-range time machine. We're looking at a project from right now, January 2026.
It feels like the future, doesn't it?
It absolutely does. It feels like something pulled straight out of a cyberpunk novel or maybe, I don't know, the background lore of a sci-fi movie. But it's not fiction.
Nope.
It's actually happening on a laptop in Spain. We're talking at the intersection of creativity, artificial intelligence, and that very specific, very human frustration
Oh, I know this feeling.
you get when you're playing a board game that is almost perfect, but not quite.
That is a feeling I think we all know, and it is a fascinating topic because it touches on something we often think is untouchable by machines, the concept of fun.
Yeah.
We are looking at a brand new blog post titled LudoForge, #1 The Domains of the Emperor Owl by John Urania.
The Domains of the Emperor Owl. I have to say, I love that title.
It's very evocative.
It sounds like a fantasy novel, or maybe a secret society, but it's actually a technical roadmap.
It is. And the mission of this deep dive is to unpack exactly what Urania is building. He calls it LudoForge.
LudoForge.
And simply put, it is a system designed to evolve tabletop game rules using what he calls a deterministic taste loop.
A deterministic taste loop.
Oh.
Okay. Now, we are going to spend a lot of time unpacking that phrase because it sounds like, I don't know, a flavor profile for a fancy coffee.
It does.
But it's actually about coding. But before we get into the heavy tech, and there's some heavy tech here, I want to ground this in a feeling.
Yeah, let's do that.
I want to take a second to connect with you, the listener, because if you're listening to this, you've probably played a game.
Hopefully.
Think about it. You sit down with a group of friends. It's Friday night. You've got the snacks. You've got the drinks. You unpack a big, expensive board game that you just bought.
The excitement is palpable.
You spend an hour reading the manual, arguing about rules. You finally start playing. And 2 hours in, you hit a wall.
The realization.
Yeah. You think, man, this combat system is sluggish, or why is the economy so random? I can't plan anything.
Or my favorite. I'm technically playing, but I haven't made a real decision in 20 minutes.
Exactly. It's the Goldilocks problem.
It is. It's too hot or it's too cold. It's never just right.
And in that moment, you find yourself wishing you could just reach into the code of the universe, or at least the rule book, and just perform surgery on the game.
A little nip and tuck.
You want to take the combat from game A because it was snappy and exciting. You want to take the economy from game B because it was deep and strategic. And you want to mash them together to make the perfect game for your specific brain.
That is the eternal struggle of the gamer. We are always chasing that perfect experience.
Yep.
And usually that is where it ends. You complain, you finish the game, you put it back on the shelf, and maybe you write a review on a forum.
But this deep dive is about what happens when someone doesn't just complain.
Right.
It's about asking a pretty radical question. What if you didn't have to rely on a human game designer to guess what you like? What if you could turn fun into a math equation?
That is a massive concept. Turning fun into math.
It feels almost wrong to say it.
It does, and not just an equation, but a target, a destination on a map. The premise here is really about using biological evolution principles, Darwinian evolution, to breed better game.
Breeding games, like prize horses.
Or like fruit flies in a lab. You breed thousands of them, look for the mutations that work, and discard the ones that don't.
It sounds a little cold when you put it that way. Discarding the ones that don't work.
Well, the computer doesn't have feelings.
I guess not. But the potential is incredible. We are trying to answer the big question here. Can a computer learn what makes a game fun? Or is fun this mystical, uniquely human trait that machines will never truly understand?
It is the ultimate man versus machine showdown, but in this case, they are actually on the same team.
A collaboration.
They are collaborating to design a card game.
So let's start at the beginning, the origin story. Urania calls this section, "The perfect game doesn't exist."
And this starts with John Urania himself. He is a Spanish writer and programmer. He describes himself as a systems builder by nature.
I like that description.
Yeah.
It implies a certain way of looking at the world. He's not just a gamer, he's a mechanic. He looks at the hood of a car and doesn't see a car. He sees pistons and valves. He looks at a board game and sees probability curves and resource sinks.
Exactly. And the inciting incident for LudoForge wasn't a corporate mandate. It wasn't a research grant from a university.
No.
It was insomnia.
The classic muse, the oldest one in the book.
The best ideas often come when you're staring at the ceiling at 3 a.m., desperate for sleep, but your brain just will not shut off.
He describes rolling around in bed, realizing that while he loves tabletop games, and he really loves them, none of them perfectly fit his brain's specific needs.
And he's not just talking about simple games here.
No, he lists some heavy hitters to prove his credentials. His favorite game is Arkham Horror LCG, the living card game.
A classic. And a beast of a game. It is very narrative-driven, very complex deck construction. It's not something you play casually. It's a lifestyle game.
Definitely. He also mentions Terraforming Mars, Arc Nova.
All huge, complex engine builders.
Baseball highlights. 2045, Core Worlds, Imperium, Labyrinth, Renegade. I mean, if you were into board games, you know this list. This is a who's who of complex strategy games. These aren't Monopolies or Uno.
No, these are what we call heavy games, systems rich. And that is significant because the more complex a game is, the harder it is to balance.
What do you mean?
Well, if you were playing tic-tac-toe, the flaws are obvious. You can see the whole game in your head. It's a solved game.
Right.
But if you were playing Terraforming Mars, the flaws are buried deep in the probability curves of the deck and the resource conversion rates. A human designer can stare at that for years and not see a flaw that a computer might find in seconds.
Right. And he says, regarding these games, none of them fully captured me. It's like he can feel the outline of a perfect game in the dark, but he can't find it. He says, I've cyclically thought that I should create that game, but I never know where to start.
That is the blank page problem. Designing a complex system from scratch is incredibly difficult. You have to invent the physics of a new universe.
You don't even know where to put the first brick.
You have to decide how many cards there are, what they do, how players interact. It is overwhelming.
But then he has this epiphany. He's been working on something called the Living Narrative Engine, doing complex analytics. And he realizes something.
What's that?
You can mathematically find gaps in complex spaces if you can define the space.
This is the pivot point. This is where he stops thinking like a designer and starts thinking like a data scientist.
And he asks the big question.
The forbidden question. Can fun be mathematically defined?
It sounds almost sacrilegious to ask that, like trying to calculate love or beauty.
Yeah, we want to believe these things are magic.
We do.
But let's break it down. If you look at a game, you can measure things. You can't measure fun directly, maybe, but you can measure agency. How many choices do I have?
Okay, that's a number.
You can measure strategic depth. You can measure variety. Urenia's hypothesis is that if you can calculate these metrics, then fun is just a fitness score that combines them.
So fun becomes a weighted average. Fun equals 30% agency plus 20% variety plus 50% explosion noises.
Roughly, yes. And if that is true, then game design stops being purely an art form. It shifts from being about invention to being about search.
Search. Unpack that for me. What are you searching for?
Think of all the possible board games that could ever exist as a giant map, a landscape.
Okay.
Most of that landscape is garbage games that are boring, broken, or literally unplayable. Those are the valleys.
So,
But somewhere on that map are the peaks.
the good games.
The Mount Everest of fun, the K2 of strategy, Urenia is saying. Instead of trying to build a mountain from scratch, let's just build a map of the landscape and use an algorithm to find where the peaks are.
That is a huge shift in perspective. It's not, I'm going to make a game. It's, I'm going to hunt for a game.
It's like being an explorer rather than an architect.
I like that.
Yeah.
And the context of this project is crucial. We are recording this looking at a source from January 2026. Urenia explicitly places this project in the era of Claude Code and Codex.
Which is, the era we're in now, these large language models that can write code.
Yeah, he mentions that he didn't even write the technical report himself. He fed his architectural documents to ChatGPT and told it to generate the report we're reading.
That is the world we live in now. The barrier to entry for building a system this complex, something that involves genetic algorithms, simulations, analytics, it has dropped massively.
So one person can do what used to take a whole team.
A single developer, like Urenia, can build what would have taken a team of 10 people just 5 years ago. It's wild.
It's empowering, but also a little scary. It means one person can generate more ideas than a whole studio.
For better or worse.
So he's got the tools. He's got the insomnia-fueled motivation. Let's get into the machine itself. Section 2. Under the hood of LudoForge.
Right. So how does this actually work? He describes it as a loop.
A loop. Okay. Walk us through the circle of life for these board games. Imagine them a baby board game. What happens to me?
Okay. Imagine a conveyor belt. At the start, you have a seed. This is a basic definition of a game, a starting point.
So not a random mess of code. The computer doesn't just start typing random letters.
No, and that is a key constraint Urania mentions. The core uses a seeded population. There is no magic generator that spits out a masterpiece from thin air, at least not yet.
So you have to give it a nudge.
You have to feed it some initial ideas. You have to say, here is a game structure. It has cards, it has health points, it has turns.
Okay, so we start with a seed. I'm a basic card game. Then what?
Then comes the evaluate and simulate phase. The computer plays the game, not a human, the computer.
It plays itself.
It plays itself hundreds or thousands of times. It runs analytics on those games. It watches itself play.
Like a coach watching game tape.
Exactly. Then there is a slot for human feedback. We'll get to that later. That's the pace part. And finally, it calculates a fitness score.
How good was this game?
How good was this game? Did it work? Was it interesting based on our metrics?
And then the evolution happens, the Darwinian part.
Exactly. It uses a technique called MA elites to select the best versions, and then it applies mutation and crossover. It tweaks the rules, mixes them up,
And creates the next generation.
and the loop starts all over again.
It's natural selection, but at light speed.
Faster than light speed. It's computational selection. It can do in an hour what biological evolution took millions of years to do.
Let's talk about what a game actually is to the computer. Because when I think of a game, I think of cardboard, plastic tokens, artwork. But the computer doesn't see that.
No.
He talks about the genome.
Right. To LudoForge, a game isn't a box with pieces. It's a text file. It's defined in a DSL, a domain-specific language.
A DSL. Hang on, what's a DSL?
Oh, right. It stands for domain-specific language.
Yeah.
It's basically a custom-built programming language just for defining these games.
Okay, so it's not like Python or something. It's its own little universe.
Exactly. And that's important for the next part. DSL safety.
Safety, like making sure the game doesn't hurt you. Or make your computer explode.
The second one, basically. Making sure the game doesn't crash the simulation. Before a game is even played, the system validates the rules.
Yeah.
Imagine the mutation step changes a rule. It changes draw 1 card to draw -5 cards.
Which is impossible. You can't hold negative cards.
Exactly. That is invalid code. If the simulation tried to run that, it would crash. The program would stop. So the system rejects it immediately.
Okay, so it filters out the syntax errors, the typos. It's like a spell checker for game rules.
Precisely. But, and this is a fascinating distinction, Urania mentions repair logic.
Repair logic.
He says the repair is conservative. It fixes technical errors like variable bounds, but it refuses to fix dumb design choices.
Wait, explain that. What's the difference between an error and a dumb choice?
An error is draw magnifique fards. That breaks the math. It's an impossible instruction.
Got it.
A dumb choice is draw 0 cards. That is valid math. You can draw 0 cards, but it makes for a boring game.
Right.
If the evolutionary process creates a game where the only legal move is to pass your turn until you die, that is technically a valid game. The code runs, it doesn't crash.
It's just a terrible, boring game.
A terrible, boring game. And the repair system won't fix that. It won't nudge it and say, hey, maybe draw 1 card instead. That would be more fun.
Why not? That seems like it would speed things up.
Because if the repair system started fixing bad design, it would be imposing the programmer's bias on the evolution. If you tell the computer drawing 0 cards is bad, you might accidentally prevent a game where drawing 0 cards is actually part of a brilliant strategy.
Oh, like maybe you want to empty your hand to trigger a bonus or something.
Exactly. You don't want to handcuff the creativity. You let the bad ideas survive the syntax check so they can fail the fun check later.
Ah, I get it. You let the bad ideas die a natural death rather than censoring them. It preserves the potential for happy accidents.
Precisely. It's remarkably principled. It's like, I will not save you from your own stupidity, Game 4000. You must fail on your own merits.
It's the only way to find surprising solutions. If you prevent weird designs, you might accidentally prevent a genius design that looks weird at first glance.
Correct.
So the game enters the arena, the simulation engine. This is where the computer plays the game.
Yes. And the key word here is determinism.
Determinism. That sounds very serious. Why is that the watchword?
Because science requires control. The random number generator, the RNG, is a seeded 32-bit LCG.
Okay, that's a lot of letters.
It's technical speak for. If you use the same seed number, the game plays out exactly the same way every time.
Why is that important? Games are supposed to be random, right? Dice rolls, card shuffles. That's the fun part, the unpredictability.
They are random for the player, but for the designer, which in this case is the LudoForge system, you need reproducibility. Imagine you have a game, and you tweak one rule. You want to know if the game got better because of that tweak.
Right, that's the whole point.
If the dice rolls are different every time, you don't know if the game got better because of the rule change or just because the computer got lucky rolls that time.
Ah.
Maybe the bad version of the game just happened to have an awesome shuffle, so the computer thinks it's great. It's a false positive.
Ah, I see. You're eliminating the noise, you're controlling the variables, you force the dice to roll the same way, so you can judge the rules, not the luck.
Exactly. Identical seeds equal identical behavior. It allows for fair comparisons between generations. It ensures that when a game wins, it wins because of its rules, not its luck.
That makes perfect sense. And the simulation has to handle failures too. He mentions safety valves.
Right. Because you are randomly mutating rules, you will create broken scenarios. You will create chaos.
Like an infinite loop.
Exactly. Imagine a rule that says, when player A draws a card, player B must draw a card. And another rule says, when player B draws a card, player A must draw a card.
Oh no, it's a ping pong match that never ends. They just draw their whole decks instantly. The game freezes.
Right. And the simulation would hang there forever. So it has loop detection. If it sees the same state repeating or if a chain reaction goes too long, it kills the game. Termination reason? Loop detected.
What about other dead ends?
It's got those covered. If there are no legal actions for any player, that's a stalemate. Call it a draw.
And if the game just takes too long?
Max turns exceeded. If nobody has won after, say, 10,000 turns, cut it off. It's a draw. The computer has other games to play. It can't spend eternity on a stalemate.
So the simulation runs, the computer plays these thousands of broken, weird, mutating games. Now we get to the hard part. How does the computer know if it had fun? Section 3. Measuring the unmeasurable.
This is the philosophical core, and Urenia is very honest about this. He says these metrics are not fun.
If they're not fun, then what are they?
They're proxies for fun.
Proxies, like shadows of fun, footprints.
Indications. Fingerprints. The idea is, if a game is fun, it usually has these characteristics. So we measure the characteristics and hope the fun is there.
Can you give me an analogy?
It's like trying to measure if a party is good. You can't measure vibes, but you can measure how loud the laughter is or how many empty chip bowls there are.
It's a strong indicator, but not the thing itself.
Exactly.
Let's go through the cheap proxies he lists, the ones that are easy to calculate. First up, agency.
Agency is a measure of choice. Specifically, what fraction of the time does the player have more than one legal action?
Okay, so if I'm playing Candyland and I draw a red card, I must move to the red square. I don't have a choice.
Your agency is 0.
Correct. You're an observer, not a player. You were just watching the game happen to you. LudoForge measures this.
If a game has 0% agency, it's a movie, not a game. But conversely, if it has 100% agency, it might be overwhelming. You want a sweet spot.
Next one, strategic depth. Sounds similar to agency. How's it different?
It is related but distinct. This is defined as the average number of legal actions available per step. It's about the volume of choice.
So agency is, do I have a choice? And strategic depth is, how many choices do I have?
Perfect. In chess, you have many legal moves at any given time. High strategic depth. In tic-tac-toe, you have very few. Low strategic depth.
So a higher number usually means a crunchier, more complex game.
Usually, though too high can lead to analysis paralysis, where the player freezes up because there are too many options.
Right, I've been there. I have 50 legal moves. I might just pick one at random because I can't calculate them all.
Exactly. So again, it's about finding that balance.
Did we have variety?
He calls this action entropy proxy. That's the fancy data science term.
In English.
Basically, are you doing different things or are you spamming the same button over and over?
So if the best strategy in a game is just attack, 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 the variety score is low.
Exactly. Even if you could do other things. If the optimal play is boring, the game is boring. The computer checks for this. It asks, did the winner use a mix of moves? Did they attack, then defend, then trade? Or did they just spam the fireball spell for 20 turns?
Pacing tension? What's that?
Steps per turn. Is a turn, I do one thing and I'm done? Or is a turn, I play a card, move a token, buy a resource, trigger an event? This measures the rhythm of the game.
So it differentiates between a quick game like, say, Uno, and a really long, involved turn in something like Arc Nova.
Precisely. Some games want short, snappy turns. Some want long, complex turns. This just measures it. It doesn't judge it.
And interaction rate.
A proxy for turn-taking frequency.
Yeah.
How long do I have to wait before I get to play again? If I take a 20-minute turn while you watch and check your phone, the interaction rate is poor.
Right, the downtime problem. Those are the cheap ones. The ones that the computer can calculate instantly just by looking at the logs. But then he mentions the expensive metrics.
The ones that take real computing power.
Meaningful choice spread. This sounds interesting.
This is fascinating, and this is where the AI really shines. It's not just asking, do I have choices? It's asking, do my choices matter?
How does a computer figure that out? That seems really subjective.
By looking into the future. It takes the game state and it simulates branches. It asks, what happens if I choose option A, and runs a simulation? Then it resets and asks, what happens if I choose option B?
And it compares the outcomes.
If both options lead to the exact same outcome in 5 turns, then the choice wasn't meaningful. It was an illusion.
Oh, that is brutal. That's calling out the game for lying to you. You gave me 2 doors, but they both lead to the kitchen.
Exactly. A high meaningful choice score means the game state diverges significantly based on your decisions. It means your input actually changes the universe of the game. If I go left, the game looks completely different than if I go right.
And the last big one, comeback potential.
This is huge for player engagement. It measures the correlation between early advantages and final outcomes.
In plain English.
If I am winning in the first 10 minutes, am I guaranteed to win the game?
If the answer is yes, that's a bad game.
Usually yes. It's called runaway leader. Think of Monopoly. You know who is going to win an hour before the game actually ends? It's miserable.
Right. If you know you've lost 10 minutes in, but the game takes an hour, the last 50 minutes are torture. You're just going through the motions.
But you don't want the opposite either, right? Where nothing matters until the last second.
Good point.
You don't want pure randomness like Mario Kart rubber banding where the person in last place gets the best items and wins automatically. That feels cheap.
So you want a sweet spot.
You want a tightrope walk. You want the correlation to be loose enough that a comeback is possible, so the loser keeps trying, but tight enough that skill and early good plays still matter. You feel like you're earning your victory.
It's amazing that they can quantify that.
Yeah.
It's like calculating a coefficient of hope.
And that is why these metrics are so powerful when combined. No single number defines fun. You can have high agency and be boring. You can have high variety and be chaotic.
But if you have high agency, high meaningful choice, good pacing, and reasonable comeback potential.
You probably have a winner, or at least something worth looking at.
But numbers aren't everything. Urini admits that. He says, metrics get you a feature vector. Humans supply the missing ingredient, taste. This leads us to section 4, the taste model.
This is where LudoForge stops being a calculator and starts being a collaborator, because you can have great metrics and still have a soulless game.
The technically perfect but boring game.
Exactly. The computer can find a balanced game, but it can't tell you if the game feels cool. It doesn't know what a zombie is or a spaceship. It just sees numbers.
So how does the human get involved?
Yeah.
Does the human play all 1,000 games? Because that sounds like a full-time job for 100 people.
God, no. That would defeat the purpose. The system uses the human to train a taste model.
A cased model.
It learns what you like. It builds a digital version of your preferences. 2 ways. First, ratings. You play a generated game or look at it and give it 1 to 5 stars. But Urania notes that this is weighted lower.
Why? Everyone understands 5 stars. We use it for Uber, for Amazon, for everything.
Because human rating scales are inconsistent. My 4 stars might be your 2 stars, and my 4 stars today, when I'm happy and had a good coffee, might be different from my 4 stars next week, when I'm grumpy and tired.
So it's noisy data.
It's very noisy data. It's subjective and fluctuating.
So what's the better way? The main signal.
Pairwise comparisons, AVSB.
The eye doctor test. Better 1 or better 2?
Exactly. Here is game A. Here is game B. Which one is better?
That is a much easier question for a human to answer consistently.
Why is it easier?
It strips away the absolute scale and just focuses on relative quality. You don't have to define what a perfect 5-star game is. You just have to say, I like this one more than that one.
And from those simple choices, the system builds a complex model of your preferences. Yes. It creates a vector that represents your taste. It learns, oh, this user prefers high interaction over strategic depth. Or this user loves comeback mechanics and hates high randomness.
It's like how the algorithm on social media figures out what you like. It doesn't ask you to rate every video. It just sees which one you watched longer, which one you scrolled past.
Similar concept. But LudoForge uses active learning. This is brilliant. The system doesn't just show you random pairs.
Strategic.
It asks you about pairs where it is confused.
Confused. An AI can be confused.
In a sense, if the model is 99% sure you will prefer game A over game B, it doesn't need to ask you. It already knows. It's a waste of your time.
So it asks the hard questions.
It asks you when its prediction is 50-50. I honestly don't know which of these you'll like more. This choice gives me the most information about your preferences.
So it's maximizing the information it gets from every question, is hunting for the boundaries of your taste.
Yes, it's trying to find the line where you switch from like to dislike. It refines the model at the edges.
And it also reserves slots to ask about underrepresented games. Why do that?
To prevent an echo chamber.
Ah,
If you say you like combat games, the system might just start showing you only combat games. It optimizes for what it knows you like. But maybe you also like farming games? You just haven't seen a good one yet.
right. It shouldn't pigeonhole me based on my first few answers.
Exactly. The system forces itself to show you different niches to make sure it's not missing a part of your personality. It explores the map of your taste, not just the one hill you're standing on.
That leads perfectly into Section 5, Evolution and Diversity. The MAP Elites strategy.
This is one of the most important technical concepts in the whole project. This is how you avoid just creating the same game over and over.
Irenia says standard evolution leads to convergence. Explain that. What is convergence in this context?
Standard evolution selects the top N candidates, say the top 10 best games based on the fitness score.
Sounds logical. Why is that bad? Survival of the fittest?
It sounds logical, but it leads to a monoculture. If the #1 best game is a fast combat game, then the top 10 will likely all be slight variations of that fast combat game. Because they are all climbing the same hill, they all found a local optimum.
So you lose all the other types of games. You lose the slow economic game because it wasn't quite as good as the combat one in that generation.
Exactly. And maybe that slow economic game had the potential to be amazing if it had just a few more generations to evolve. But it got killed off early because it couldn't compete with the combat game right then.
It's like cutting down a sapling because it's not as tall as a full-grown oak tree yet.
That's a great way to put it. You destroy potential diversity.
So how does MA Elites fix this?
MA Elites stands for Multi-Dimensional Archive of Phenotypic Elites.
Whoa, let's unpack that. That is a mouthful.
It is. But the concept is actually pretty intuitive. Think of it like a grid. Or better yet, a trophy case with many different shelves.
Okay, trophy case.
You define niches or bins based on descriptors. These are your metrics from before.
So like high agency is one shelf, low agency is another.
Sort of. It's multidimensional. So you have a bin for high luck, low strategy, and another bin for low luck, high strategy, and another for short game, high interaction. You slice up the world of possible games into these little boxes.
Okay, so we have all these little boxes.
The system keeps the best game for each bin.
So the best fast combat game survives. But the best slow economic game also survives because it's on a different shelf. It doesn't have to compete directly with the combat game.
Exactly. It's like the Olympics. You don't just keep the fastest athletes overall. If you did that, you'd only have sprinters.
You wouldn't have weightlifters or archers.
Exactly. You keep the fastest swimmer, the strongest lifter, the best gymnast. They are all elite, but in different dimensions.
That ensures diversity. You're building a zoo of different animals, not just a cloned army of the single best animal.
Correct. And that is crucial for creativity. Because sometimes, to find the highest peak, you need to start from a different mountain range entirely. Maybe the breakthrough comes from combining a swimmer with a weightlifter.
So we have our zoo of elite games. Now we have to evolve them. Mutation and crossover.
This is the mechanics of change. Mutation is small tweaks, little nudges.
Like changing a number.
Damage 5 becomes damage 6, or toggling a Boolean, allow trading, true becomes false. Or cycling an enum. Phase order, draw then move, becomes move then draw. It's refining an existing idea.
But then you have crossover. This is the big swings.
This is the fun part. This is taking two games and swapping parts of their DNA.
I'll take the combat system from game A and the economy from game B.
Exactly. Swapping subtrees of code. This is where the magic happens. You might combine a stable economy with a chaotic combat system and discover a mechanic that no human would have thought to combine. It's where true novelty comes from.
But again, you have to validate it every time.
Always. Every time you mutate or crossover, the DSL validation runs instantly. If you broke the code, that child dies immediately. We don't waste time on broken toys.
Now, even with all this validation, Irenia mentions a big problem. Section 6. Degeneracy. Killing the broken games.
He says evolution is lazy. And he is so right. Artificial intelligence is incredibly lazy.
What do you mean by lazy?
It will optimize for the metric regardless of the spirit of the game. It will find the shortest path to a high score, even if that path is stupid.
Give me an example of a lazy optimization.
Imagine you tell the computer, maximize the probability of the player winning. You want a game that makes the player feel powerful and successful.
Okay, that sounds like a reasonable goal.
The computer evolves a game where the first card says, you win.
Well, I mean, it did what you asked. The probability of winning is 100%.
It did. It's 100% effective. But it's a degenerate game. It has zero gameplay value. It's a technical success, but a design failure.
It followed the letter of the law, but violated the spirit.
Completely. And evolution is full of these loopholes. So LudoForge has to hunt for these cheats.
So it has degeneracy detection. It's like an anti-cheat system for game design.
It is. It hunts for trivial wins, like the one we just described. It hunts for stalemates. It hunts for dominant action spam.
That's the spam the A button problem we talked about earlier.
Yes. If the simulation notices that in 90% of turns, the winning player takes the exact same action, it flags the game as degenerate.
It says this is boring. Kill it.
This is a solved, uninteresting game. It also looks for forced move games where there's zero agency.
It's like a teacher watching a student trying to cheat on a test. No, you can't just write C for every answer, even if C is right 25% of the time.
And the clever part is these flags become part of the feature vector. The system learns to avoid them.
How does it do that?
It learns that games with this specific rule structure tend to lead to button mashing, so it starts giving games with that structure a lower score, even before simulating them. It stops exploring that path. It learns from its mistakes.
It learns from the trash it produces. It realizes that certain combinations of rules always lead to garbage, so it puts up a do not enter sign on that road.
A very apt metaphor.
So we have the loop. Seed, simulate, measure, taste, evolve, kill the degenerates. Section 7, the philosophy and future. Where does this leave us?
Karenia is very clear about the status. This isn't vaporware. This isn't just an idea on a whiteboard.
It's real.
The end-to-end tests work. The pipeline is real. The phases, the rejection logic, the safety cutoffs, the human prompt loops, it all works. This isn't just a theory. The code is running.
But he also says something very important about his goal, something that I think is crucial. He says, I am not building a game designer replacement.
That is the key takeaway. He is not trying to put people out of a job.
So what is he building?
He calls it a design pressure cooker.
I like that image. Explain it.
The goal isn't to press a button and have a finished, polished product come out that you can sell at Target. That's not it. The goal is to simulate hard, reject degeneracy, measure what you can, and let evolution explore the breadth of possibilities.
It's an idea generator. It's a way to brainstorm 10,000 ideas in an afternoon.
And not just random ideas, vetted ideas. Ideas that have already survived the pressure cooker. They are mechanically sound, they aren't broken, they don't have infinite loops, and they are starting to fit your taste profile.
So the human designer's job changes.
Completely. The human designer picks up the survivor, the elite, from one of the maybe elite's bins, and says, okay, this mechanic is brilliant, but the theme is nonsense. I'll polish this into a real game.
It moves the designer up the stack. You aren't fiddling with the basic math anymore. The computer did that. You are curating. You are refining. You are the director, not the grip moving the lights.
It shifts game design from bricklaying to sculpting.
Or gardening.
Gardening is a great metaphor. You plant the seeds, you weed out the bad ones, you water the good ones, and you see what grows. You are guiding nature, not building from scratch.
Urania ends the blog post with a summary of the mission. He says, if you're into procedural design, evolutionary search, or just enjoy the idea of treating fun as something you can iteratively approximate with a human-in-the-loop model, that's what this project is for.
It represents a fundamental shift in how we create. We used to think creativity was purely about the spark of inspiration, the lightning bolt from the sky.
The lone genius.
The lone genius, right. This suggests that creativity can also be about filtering. If you can generate enough options and filter them intelligently, the result is indistinguishable from genius.
It's the monkeys with typewriters theory, but the monkeys are supercomputers, and we have a really good spell checker.
And a really good editor telling the monkeys, I like stories about detectives, write more of those. That's the human taste part.
So let's bring this back to the listener. Why does this matter to someone who isn't a game designer? Why should the person driving to work right now care about this?
Because this isn't just about board games. This loop, generate, simulate, filter with human taste is applicable to almost anything.
Like what?
Architecture, storytelling, diet plans.
Imagine a LudoForge for your weekly meal prep.
Exactly. I want something that is healthy, cheap, and spicy. You filled that into the system. It generates 1,000 meal plans. It simulates them. Does this meet the nutritional requirements? Is it within budget? You give it pairwise feedback. I like the chicken dish more than the fish dish, and it presents you with the elite options.
Or a LudoForge for interior design.
Yeah.
I want a living room that encourages conversation, but also has a TV, and it evolves the layout for you.
It's a tool for the insanely curious who want to understand why they like what they like.
What do you mean by that?
By seeing what the computer serves you, and by making those A/B choices, you learn about yourself. The system might show you 2 games and you realize, oh, I thought I liked complex strategy, but actually the computer noticed that I consistently rate dice rolling games higher. I just like the thrill of gambling.
The machine acts as a mirror for your own taste. It quantifies your preferences in a way you couldn't do yourself. It knows you better than you know you.
That is both a comforting and a slightly terrifying thought.
And that leads to my final provocative thought. We started by saying Urania wanted a game that fit his brain perfectly. If LudoForge works, if a computer can learn your taste model better than you can describe it yourself,
I see where you're going. This is the big picture.
could we be moving toward an era of personal bespoke gaming, where the game I play is different from the game you play, even if they have the same name?
The rule set dynamically adapts to your playstyle.
Or where I don't buy a game off the shelf at all. I just tell my home server, make me a game for a rainy Tuesday, and it generates a unique experience just for me that will never be played by anyone else in the world.
That is the ultimate promise of this technology, the death of the mass market and the birth of the market of one.
A market of one.
If the cost of design drops to near zero because the AI does the heavy lifting, then why shouldn't everyone have a game designed specifically for them? Why wear off-the-rack clothes if you can have a tailored suit for the same price?
It's a wild thought. A world where culture becomes hyper-individualized, whether that's good or bad. Well, that's a whole other deep dive.
Indeed. But for now, it's exciting to watch the first steps. This is the ground floor.
Absolutely.
Yeah.
So next time you're playing a board game and you think, I wish this one rule was different, remember, somewhere in a computer in Spain, an emperor owl is trying to fix it for you.
The Emperor Owl knows best.
Thanks for listening. Go tweak some variables in your own life today. We'll see you in the next deep dive.